Okay, we're here today. We are going over lesson 6.2 in statistics. This is going to be confidence intervals for the mean when we have a small sample size. Okay, when we're taking a sample, oftentimes our population standard deviation is unknown, and it's not practical to collect 30 samples. So what we're looking at, what can we do if we don't have 30 samples, 30 samples taken, and we don't know our population standard deviation? Can we still construct a confidence interval for our population mean? Yes, we're going to be able to do that, and we're going to use what's called the t-distribution. Okay, we've previously used a z-distribution. Now we are going to use a t-distribution. Okay, if you look there in that orange box on your in your book there, they give you how we calculate this t. We would have our sample mean minus our population mean divided by the sample standard deviation, which is also divided by the square root of the sample size. Okay? So a couple of things to note. Our t-distribution is going to be bell-shaped. It is going to be symmetrical about the mean. Okay? It is going to be a family of curves, and each of those is going to be determined by the parameter degrees of freedom. Okay, we're going to have this idea of degrees of freedom. Okay. All right, so degrees of freedom, that's going to be the number of free choices left after a sample statistic is calculated. Okay, the number of free choices left after a sample statistic is calculated. When we're using a t-distribution to estimate the population mean, the degree of freedom is going to equal n minus 1. All right, so when we're using the t-distribution, the degrees of freedom is just the sample size minus 1. Okay, the area underneath our curve, just like before, is going to be 1 or 100%. All right. And then if you look at there on the page there, you see those 3 different graphs. What that is showing you is as my degrees of freedom decrease due to my sample size increasing. Okay, so as the degrees of freedom increases because my sample size is increasing, my t-distribution is going to approach the normal distribution. All right, so if you look there at that diagram there, we've got this right here, and they showed this right here, okay, basically coming down. Oh, that was lovely. That's not what I wanted it to do. Okay, so here we have this. Let me let this not touch, which it shouldn't actually touch. Okay, so I've got this, right? All right, and this is going to be the standard normal curve. Okay, well, if I'm creating a t-distribution and say my degrees of freedom is 5, so we're going to draw another one here where so I'm going to have this other one where my degree of freedom is going to be 5. Okay, this is going to start up a little higher right here. It's going to go up and it's going to come down a little lower than that other curve, and the tail, notice, doesn't come down as low. Okay, and then let's do another one here. We're going to have the degree of freedom equals 2. Okay, this is going to start even higher. All right, it's not going to arch up quite as far. Okay, so notice here, if I have a degree of freedom 2, which means I have a smaller sample size, my curve is kind of, it's shaped like the normal curve and everything, but it's not, it's a little ways away. But the larger my degree of freedom, okay, the closer that curve gets to being the normal curve. All right, that's what they're wanting us to show us there. Okay, they've given us this wonderful formula there. What's even nicer is they've given us a table in the back that we can use to find these critical values of t. All right, just like we had the critical value of z, we're going to have this critical value of t. All right, we can use a table. It's going to be table number 5 in the back of your book. Right now, you can flip back there if you want, but otherwise, we're going to look at example 1, and that's going to let us work with a little bit of that table. Okay, if you look at example 1 there, it shows finding critical values of t for a 95% confidence when the sample size is 15. Okay, so if our sample size is 15, our degree of freedom is going to be 14. All right, so just you look at the table right there, you see down the left-hand side the degrees of freedom. They've got 1, 2, 3, 12, 13, 14, 15, 16. Okay, so we're looking at our degree of freedom is going to be 14. Okay, now go across the top of the table and they show you different confidence levels, 50%, 80%, 90, 95, and 98. So we're going to go down the 95% column and we're going to see that our critical value for T is 2.145. Okay, they've also given you there what the value is going to be in the tail. All right, and so if we have one tail, for the one tail, we're going to have this 0.025. For two tails, we're going to have 0.5. Okay? All right, so we'll deal with that a little further later on. All right, so you can just look there. They go ahead and show you the graph there from the table. We've seen what our t-value is going to be. So if we were to graph that, think about the fact that we would do just like normal. We would have our nice graph, okay? We're going to have our area here, and then these values are going to be that 2.145, and over here the negative 2.145, right? Okay, and this area under here, that's our C equals 95, so that's our 95% confidence, okay? So we're 95% confident that our mean is going to fall in this area, okay? All right, over here, this is super simple. We're going to look at if we want to construct a confidence interval for the mean using the t-distribution. So we're going to construct a confidence interval for the mean using a t-distribution. Okay, if we're looking to do that, okay, first thing we need to do, number 1, is determine n, our sample size, our sample mean, and our standard deviation, or the sample deviation. Those are generally going to be given to you, right? The next thing we want to make sure that we do is that we know what is our confidence. What is the confidence level we're desiring? What is our degrees of freedom? Okay, remember that, and then also, what is our critical value for C? Okay, the confidence level is going to be given to us. All right, our degree of freedom is going to be our sample size minus 1, and the critical value for T, you're going to use table 5. Okay. After that, we want to find E, that margin of error, right? Okay, and remember we have our equation when we're looking for E. This time we're going to use the critical value of T times my sample standard deviation divided by the square root of my population size. Okay, and then we're going to find our endpoints. All right, and with that endpoints, what I'm doing, I'm going to add and subtract that margin of error. Okay, so the left is going to be my sample standard and my sample mean minus the mean margin of error. My right is going to be my sample mean plus my margin of error. Okay, and my interval, okay, I'm going to have that the population mean is going to be greater than the sample mean minus the margin of error, and it's going to be less than the sample mean plus the margin of error. Okay? Very similar to what we have already been doing, actually exactly like what we have already been doing. We're just using a little bit of a different formula there. Okay, so let's look real quick at example 2. All right, example 2, we're going to some coffee shops, and we are going to take samples from 16 coffee shops. We are checking what is the temperature of the coffee that is sold. The sample mean temperature of the coffee is 162 degrees. We're told that there is the sample standard deviation is 10 degrees in the temperature of the coffee, and they want us to find a 95% confidence interval for the mean temperature of the coffee. So C is going to equal 95. And they tell us to assume that the temperatures are normally distributed. Okay, so I'm going to take all of these things. I'm going to go back to my table. All right, oh, think about this also. With that n, I'm going to be able to calculate my degrees of freedom are going to be 15, right? And actually on that table, what I really need on that table is just these two things right here, my confidence level and my degree of freedom. And I think even this right here is going to show up over here if you look over on example 1, that if you look at across the degree of freedom 15 column and the 95%, you're going to find that our critical value for T is going to equal 2.131. Okay, you don't even have to flip to the back of the book. Okay, so now we need to calculate our margin of error. So E is going to equal that 2.131, okay, times S, which is 10, divided by the square root of N, which is 16. All right, so I've got those things there. When I calculate that out, I'm going to get 5.3. All right, so that's going to be my margin of error. Okay, so think about the fact my sample statistic was 162. So I take the 162 plus 5.3 and the 162 minus the 5.3. Okay, and this is going to give me over here 167.5, over here 156.7. Okay, so my interval is going to be here, right? And my mu is going to be less than this and greater than that. So if I'm looking at that, to put that on a number line, okay, say that we had, 160 and 165 out here and 155 over here. If that was just my standard number line, well, I would plot this place right here as 156.7. I would have over here 167.5, and I would have right in here my 162. Okay, and your interpretation is that I can say with 95% confidence that the mean temperature for coffee sold is between 156.7 degrees and 167.5 degrees Fahrenheit. That the mean temperature of coffee sold is 95% confident it's between those two values. Okay? All right. They have got for you, if you flip on over to the next page, let's see, there's actually another example. Let's look at this other example real quick. Okay, we are randomly selecting 20 mortgage institutions. So, excuse me, my N is going to equal 20. Okay, we're going to determine and we're looking to determine the interest rate. All right, so my sample mean is going to be 6.22%. My standard deviation is going to be 0.42%. My confidence level that we're looking for is 99%. Okay, I can figure out that my degrees of freedom are going to be 19. If I look in the back of the book, I'm going to get that my critical value for T is 2.861. All right, now I'm just going to have to calculate my E, which is going to equal that 2.861 times the S, 0.42, over the square root of n, which is 20. So I'm going to get over here this 0.27. Okay, and so then remember that I find my interval by taking my sample statistic and adding and subtracting this amount right here. Okay, so when I do that, the 6.22 minus the 0.27 is going to give me 5.95. When I add it, I'm going to get 6.49. So I know that I can have, with 99% confidence, I can say that the population mean is between 6.49 and 5.95. Okay? All right. Other thing here, if you look at the top of page 329, they just give you a nice little flow chart for you to be able to figure out whether or not you're going to use a normal distribution or if you're going to use the t distribution. Okay, so this is knowing when to construct a confidence interval for the population mean and when to use a t distribution. Okay, so look in here. Is n less than, greater than, or equal to 30? If it is greater than 30, then they're going to tell us use that normal distribution, where our margin of error, we get the z-score, okay? If the standard deviation is unknown, remember that we could use S instead. Okay, if we came down and said, no, my population is less than 30, all right, then we want to know, is it normally or approximately normally distributed? Okay, if it's not, I can't use the normal distribution or the t-distribution. But if it is normally distributed, then the next thing I look at is whether or not I know the standard deviation. Okay, if I do know the standard deviation, I'm going to go ahead and use that normal distribution. If I don't know it, then I'm going to use the t. So basically, you're using the t distribution if your sample size is less than 30 and you do not know your standard deviation. You'll use the t. Okay? If it's less than 30, you can go ahead and use your normal distribution, but you have to know your standard deviation. Okay? So just example 4, there it says you randomly select 25 new houses. So I've got n equals 25. It says the sample mean construction cost is $181,000, and the population standard deviation is 28,000. Assume construction costs are normally distributed. Should you use the normal distribution, the t-distribution, or neither to construct a confidence interval of 95%? Okay, well here we know this is normal, all right, and we've actually been able to give us the population standard deviation. They gave us the population standard deviation. Oh, yeah. Oh, I wrote it as the mean. Sorry, guys. The population standard deviation is 28,000. Okay, so I know it is normally distributed, and I do know this right here. Therefore, I can just, because of that, we can just use a normal distribution. All right. If I didn't know this, if I didn't know my standard deviation, then I would use the t. Okay. All right, that is all for this lesson. This was wonderfully easy. I hope you guys have a wonderful week.